Dennis. I'm one of the co-organizers of this meetup, along with Lisa. Super thrilled to have Declan presenting today. For those of you who don't know him, he's actually the person that started this meetup over a decade ago. And I don't know, he's been one of my agile mentors right from the beginning, I'd say, and he tends to focus any more on the technical side, and I'm really looking forward to hearing his experience and wisdom about doing evolutionary architecture. So please welcome Declan.
Is that music distracting?
Yes.
Yeah. So we're going to talk about evolutionary architecture, and it's definitely in an agile context. And is there anything that anyone was sort of curious about with this session that said, aha, I would like to know something about architecture, or in sort of like this agile lean context? Is there anything?
The notion of the architectural runway.
Okay.
And laying the runway sort of ahead of it. Something just, kind of a term that I've been reading a little bit about.
Right.
If there's any...
Like from the SAFE, it
Yes.
has an architectural runway.
Yes.
Yeah, good, right. Okay. Anything else?
I would also say the transition to agile from like a waterfall and how architecture kind of flows into that, / the fear of moving over to agile.
Right. So is your company going through that transition and architects feeling challenged around that?
Yes, a little bit of holding on too much as opposed to and that worry and that fear factor of if I don't follow my old principles, it's all sustainable.
Right. So,
I have one.
yeah?
How you apply evolutionary architecture to legacy projects, especially big or very big projects?
Yeah. Okay. That's advanced. Yeah, so I think what I wanted to show is some of the techniques that I've learned recently about building systems so that they can evolve over time, and how do you do that sort of in an agile context. Because like one of the biggest challenges that I've faced is, when you build a system in the old days, let's rewind like 20 years, you would have a project plan, and you'd have an architecture phase, and so on. And you'd have this time and space carved out for architecture. And we sort of look at that now and go, oh, how sort of quaint that was, right? But it turned out to be pretty effective because you have a chance to really dig into some important sort of system-wide concerns and decide what's important, is it scalability, performance, et cetera. And now fast forward to Agile, and we're sort of saying, okay, here's your first sprint. You have to have something working by the end of the sprint. Like, where is the time and space to do effective architectural design? So I think this is a struggle that I've seen. I've also seen companies that still proceed with doing sort of traditional architecture, and then they sort of have this impedance mismatch because they have these grandiose plans for what the system should be, but their teams are building in the here and now, and how do you connect, how are you actually able to build incrementally and still sort of move closer to some architectural vision. So those are sort of like the things that I want to talk about, and I hope some ideas that might help you. It's very high level. It's going to be low on kind of like how you would actually do this in your company. I'm going to be drawing sort of a broad brush around techniques that I've started to use in my work, and I think make a ton of sense. So,
Excuse me.
Yeah.
Can you turn down that music?
Yeah, I can still better. I'm still feeling the urge to dance.
Yeah, that's cool.
Okay, so I'll show you some examples of anti-patterns, big design up front. Has anyone seen this? Where you design it and it turns out that you probably will very likely over-design it because you're anticipating things that might never come to fruition. You're anticipating certain security things or configurability, et cetera, et cetera, et cetera. So you load this up into something that would be really awesome, but at the end of the day, this is really hard for Agile teams to execute. So this big design up front is an anti-pattern. Actually, it's called BDUF if you ever see it. But some design up front is probably a good one. But all the design up
Especially if you're
front,
building one of them.
yeah. Just too much detail, too much design up front. I was working on a project recently where they had an architect who designed the whole system up front, identified components and boundaries. It was going to be this Java thing, and it was all beautifully designed. Then they switched to said, well, really, we think microservice architecture would be better, and all the work that this architect did was just like now useless. So that big design up front can lead to a lot of waste. Of course, the opposite of that is no design up front, and so there's something in between. And this I think is a pretty big risk for agile teams because they're under this pressure or this expectation of releasing every week or every 2 weeks, and it's really easy to sort of skip over the design stuff and just start coding and then sort of have just build more and more technical debt if you're not careful. Anyway, and if you do build technical debt, you end up with this big ball of mud. I don't know if anyone's worked on a system like this where it just seems like everything's interconnected and you go to change one thing and there's some weird effect somewhere else, and it's really, really hard to work in those systems. And that's actually a term. If you Googled big ball of mud, you'll find a really good article from the 90s. That looks like this from the 90s because it has horrible colors. It looks like a blog post, but the sort of interesting stuff there, how we end up with big balls of mud. We definitely don't want systems like that. And I don't know if anyone else has seen this. If a framework is good, use it. Classic examples, although I haven't used Spring Boot. Some Java developers using Spring Boot. There'll be these frameworks, or if you're using Rails, or if you build there's this framework, this framework can do this, and there's this sort of attraction to leveraging all of the things that the framework can do. And lots of times that's probably a bad idea to couple yourself too much to a specific framework. So that's sort of an anti-pattern that you just get locked in. And a related one is the vendor trap, where a vendor will give you some framework or some solution, and usually those things look like they'll accelerate your time to market initially, and so the initial 80% is usually yeah. But if you're designing a framework, you're optimizing for a certain use case, and eventually you'll run up against a use case that they deliberately did not optimize for. They made some things easy and some things hard, and eventually you sort of get this 80%. You get 80%. I find is actually generally, if it's close, if you picked a good framework, you'll be good. The next 10% gets like super hard because it wasn't really designed for that, and the last 10% can often be impossible or extremely difficult, not worth doing. So you get this trap of getting these vendor frameworks, and of course, some of these vendors are really good at selling their wares, and they're very good at wooing managers. So you have to be careful of that too. Another anti-pattern is this ivory tower architect. Oh, here's this beautiful architecture in the sky. I bequeath this to you. Please build it. And that vision is not grounded in the reality of actually making it work. How do you test it? It's actually working in. And the architect will always say, well, I've designed a beautiful architecture. What's your problem? Just please build it for me. Is anyone here an architect, by the way? With substance, quite a few. A couple. Yeah. And, I've been guilty of this for sure. Or abdicating is sort of related, like the bullying. I've told you what to build, you just go build it. That's your problem, it's not mine. If there's some issue with the architecture, well, that's okay. That's your problem to resolve. I'm no longer involved. I've done my job. I architected it, you go build it. And so we can sort of get stuck in this mode of how do we actually proceed to make progress towards some architectural goal, while at the same time being able to deliver at sort of an agile cadence of every week or two, or perhaps every month. So So I want to introduce the idea of evolutionary architecture, and it comes from this book, and I'll give you a picture at the end. This came out about a year, maybe 2 years, about a year ago, and it's quite a good book. And they talk about, the whole book is on evolutionary architecture. And so they describe it as it supports guided incremental change across multiple dimensions. So it's not about building the beautiful architecture, it's by putting in place a system that lets you evolve to that architecture. And this should be contrasted with, has anyone heard the term of evolutionary architecture? Yeah. You might have heard another term, which I was originally sort of conflated, which is called like emergent design. You've heard of emergent design. And they're actually quite different. So here the architecture is, we have a vision for where we want to go. We want to guide development towards that vision. And maybe our vision shifts when we learn more. Whereas emergent design is, we're building this code, and all of a sudden we look at it and go, oh my gosh, I see this pattern, this duplication here, we could extract this common service, etc. So it's like the system is, you're learning by the system coming back at you. It wasn't guided, you're actually looking at what was built, and it's informing how it works. And I think they play well together, but they're quite separate. In this talk, I'm only really going to talk about the evolutionary architecture, not about emergent design. Does that make sense?
Just one quick question.
Yeah.
Do you address the issue of the customer then keeps evolving as well as to what their requirements are
Yeah, but yeah.
over years? Like,
If I don't cover that by the end, bring me back.
I mean, we're dealing with systems that are 15 years old.
Yeah,
And
yeah.
I mean,
It's
Yes.
tough. Yeah. So I don't know if you can see that yet, but basically, if you equate it to dogs, we've built dogs. We've designed dogs, basically, and they're fit for purpose. We have hunting dogs. I actually have a Portuguese water dog who's supposed to be a dive off boats and fish things off the bottom. She's afraid of the water, sort of. So she's sort of a failure as a Portuguese water dog. But you get the idea that we design these dogs for purpose, and that's sort of what our architecture should be. Is that we're designing our architecture with some end in mind. It's fit for the purpose of our business.
There's a framework for the dog which is called Wolf.
Yes.
And that's the way for vendors to sell sometimes you that sort of design which you buy or part of the design.
Yeah. So back to the vendor trap. Yeah. So I just point this out as just like there is no best architecture. I'm really trying to say that your architecture is what fits your business purpose. And microservices are all the rage, and they probably are generally, a good general architecture, but they might not be the right one for you. If you have a legacy system, it might not fit. Yeah.
Can you explain what microservices are for some of us who might not
Oh,
know?
yeah. That's good. So, now you put me in a spot because there's so many definitions of microservices. But a microservice is usually a small, I think of it primarily as a small service that just does ideally one thing and one thing well. Ideally, I like to have a microservice be something conceptually that you could build in a week. It should be super lightweight, like ideally like in the range of 20 to a few hundred lines of code, and it's separately deployable and usually has no shared data with anything else. So
but in a big solution, you need 200 or 300 of them.
you might need a lot, and that brings in its own
That's got
complexity.
its own
Yeah. In
communication.
fact, I think it's one of the biggest challenges which other people are handling with Kubernetes and deployment. So yes, you're trading one complexity for a deployment challenge, right? And a versioning, et cetera, et cetera. Often people have microservices that are response related. They'll be like a JSON, typically send a request, receive, but they don't need to be. I've written lots of services that are just like they just start up and they schedule things. Like they actually don't respond to requests. They just fulfill some purpose and they wait for something to happen, like a database trigger or something. They may not necessarily be an API to them, although most tend to have. Does that make sense? Did that make sense for microservices? And it's sort of architecture du jour. So I've decided to look at this book and these ideas of evolutionary architecture and try to think about like, what would it actually mean in practice. And I've got this idea of having a double loop architecture, where on the outer loop, we're starting with business goals. I think this is like super important. Like the architecture should be hinged not on sort of like what we think architecturally would be awesome. It should be driven by what does our business need? Do we need a scalable system? How big, how scalable does it need to be? Is it more important to be secure or scalable? What about performance? So those things should not be answered by the architects. Those should come from what is our business? And then our architecture should be aligned with those business goals. I mean, it seems obvious, but too often, especially with sort of the ivory tower architecture, they're sort of building the architecture that they think is awesome and so on, and not really connected to the business value. So I'm going to spend a lot more time dealing through this, but I just want to point out, like, business-driven is probably number one, and that keeps you close to what's important, for your business. And then we define some architectural qualities. Sometimes these might be called non-functional requirements in some situations. And from that, we'll talk about guidance, which is identifying some work. We'll have some architecture decisions. We're going to build this piece. We'll go build it. We'll put some measures in place, and we'll see how we're doing against some non-functional requirement. And the idea with the double loop is that we continually review, are we actually still interested in having scalability like X? Or should now our shift be to security or something else?
I have a question. So how this fits with the startup that they try to build a minimal viable product? I don't know, do they think about architecture quality? They just go and build it, yeah? Or
I think this would fit pretty well. In fact, I'm working with an organization right now. We're going to do this to help them design their MVP, because they have the business folks that want some things and the technical folks want some other things. So the way to bring those together is here. So I think it can be applicable, but it might be a lot lighter weight. You might not spend a lot of time on this in a startup. Especially if your biggest issue with a startup is, will our customers buy it? Maybe you don't care about architecture initially, and that would be fine, as long as that's an intentional decision. And that would imply that you're willing to throw it away at some point.
so then you could start with this, yeah, with this model. After you have like kind of proof of concept or something.
Maybe, yeah. So here's the first principle I want to introduce is evolvability as a first-class concern. To me, it's less about having the perfect architecture in the sky. It's more about making sure that you can build something that is evolvable to where you want to go. So making things that are changeable and you could swap things out later. But making it so that we're going to build something and we can evolve it towards where we really want to be. And I've worked with architects to get really attached to their vision, technical vision of what should be. And I'm one of those too. I have lots of ideas. I think here's what it should be. But the idea is, well, let's just make sure that we build it so we can evolve to that. We don't have to build that out of the starting gate.
Or in this case, devolve, because most airplanes don't have that anymore.
Yeah.
They put seats there and fly passengers.
Next principle, sort of related, is changeable deferred decisions. And this is where a startup might potentially get hung up, because as soon as you decide we're going to build it in JavaScript, that's an important decision that you're making, and that might be an expensive one to change down the road. It might not be, it might be, it might not be, but being aware that when you're making decisions, if you can design it so that we can defer that decision. Like maybe security isn't important now. Let's not architect our security thing. Let's just have simple username, password, and defer how we're going to do single sign-on until later, until that becomes a priority. Or it's changeable. We're going to use SQL Server for now for our database, but we're going to make sure that we design it so that if we switched out to another database down the road, that's not going to be a big deal. So that evolvability and the changeable, deferrable decisions is really, really important. Do I need to make that decision now? Can I safely defer that decision? And anything you can defer, you want to safely defer.
But then you have to define how long you defer. Yeah, what's the best moment to decide that deferring
And that's
is
the art
enough?
of being a good architect and so on, is now the time, right? But it should be driven by, hopefully, again, by a business driver that's forcing us to shift to that direction. Our database is no longer performant based on the demand that we have. How do we switch to a multi-tenant, blah, 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 database down the road? But
Because I see the risk if you defer it too long, then the cost to, if you realize that the decision is wrong, then the cost to backtrack and change it, it's higher, yeah?
And here's the art in building, it's why I'm a big fan of agile development and writing tests around code and designing things and refactoring so that your code is always in as good a state as you possibly can to augment it to shift to some other thing. So for example, the reason what I do in my code is anything that's vendor related, I try to treat as that has minimal impact on my design and code as possible. And all my business logic would be divorced as much as I possibly can from frameworks and databases and networks, and keep that core technology close. So keep your core logic inside, so that all of the things that you depend on would become changeable. Good enough, or sacrificial architecture, good enough for now type of idea. Good example, does anyone use Twitter like about 10 years ago? You used to get the...
I finally started this year just
Oh, it is?
for
I
trying.
started about 10 years ago, and it used to fail all the time. There's the fail whale. Do you ever see the big fail whale? And that's because they built it on Ruby and Rails. And they've now re-architected, I'm not exactly sure what it is, but they realized that using Ruby and Rails helped them get to market super fast, but it wasn't the architecture that was going to support the volume that they have now. And they sort of knew that. So they built it to get market presence and so on, and they threw that architecture away and replaced it with something that was more scalable. Or another one is similar, is just building prototypes. We just want to put something in front of the customer, but there's always danger with these, right?
They become production code.
Yeah.
I mean,
But so there's a big risk with prototypes. So with a prototype, you absolutely have to be prepared to throw it away. Right? Because if you're going to make a production code, then you want to put tests around. Like, you're going to architect it all this way. And if you want to get to market quickly and find out if the thing is good, you probably don't want to invest time in all of this good engineering work if it might be thrown away. So this is a tricky one and a tough trap, because people will build stuff and then have to support it. I've been experienced this multiple times. I bet you have too. So we'll look at some things that might be a good practice. Would be having an architectural workshop. So the idea is bringing all of the people together that might be interested in architecture. I'll give you some more details on what that might look like, but basically, instead of having the ivory tower architect, have people contributing together. I see it especially with developers, because if the architects are making all these decisions and then it's thrust upon the developers were not involved in the rationale or the thinking, so to them it just looks like something's being imposed on them, especially if they don't even agree with it. That's not a good spot to be. So getting people together so that we are aligned around what we want to do architecturally.
This is dangerous, huh? It's dangerous because you could get in the indecision of the group.
Yeah.
We have different opinions, and you need an expert to...
You definitely want to have some conceptual integrity around the whole architecture, but you just don't, but you want to make sure that you listen to people who are, like, if the architect is not the one that is actually writing the code, they need to be empathetic towards the people that are actually making that architecture come to life. Because those people might have some issues with particular choices, right? This is just about, all of this is a balance, right? You're right. Like, if you have an architect who has a clear vision, yes, you want to make sure that that's honored, but you don't want to throw it down on the teams either. So you have to find a way to communicate it and get buy-in for it, get people excited about it. This is one that is sort of obvious, but I see missing a lot. It's just making your architecture visible. Like, if you walk into a team area the architecture should be up on the wall. And then if we're talking about a database component, I can sort of say, hey, what about our database wrapper? Like, we can point to it and talk to it, and it helps make it more real for people. And then you're forced to give things good names, which is always the hard part. One of the hardest things to solve is, what do we call that? Should that really be called a database wrapper? Maybe, or should that be called an adapter? What's the right term? I think very accurate with our terms. Also comes about from the English. So I want to introduce an idea that came from genetic engineering called fitness function. And so a fitness function is basically some computation that measures how effective something is. So in genetic algorithms, what they'll often do is they'll have, like, let's say, take the, you know the traveling salesperson thing, where there's, what is the, minimum path to go to these 12 cities, right? So you could try different algorithms on that. And in each algorithm, you might say, okay, well, let me measure the effectiveness of these algorithms by, say, the total distance. And I'll measure the effectiveness of those algorithms. So that total distance is the fitness function. You're measuring the effectiveness of that thing through some computation, and you measure how well it is. And the idea with fitness functions is that we want to apply fitness functions to our architecture to measure how good is our architecture. And this sounds a bit abstract, but it's actually easier than it sounds. Here are some examples. So we could do a static code analysis. So let's say, cyclomatic, we want to make sure our code was simple and easy to understand. So we could use cyclomatic complexity to measure the complexity of our code, and then we have sort of, now we're able to chart, graph, manage that. If we see it going up, we go, oh, there's an issue here. So it gets sort of related to making it visible, but by having a concrete function that's measuring the qualities of our architecture. So think about all of the ilities that we would like in an architecture: availability, security, usability, et cetera, et cetera. If we can figure out how to measure that thing, then that's really powerful, because then we can put it in our, if we have a continuous delivery pipeline, we can put that measure in our pipeline, and now we have ongoing measures, or some of it could be actually from production data. We have a way of visualizing how well is our architecture doing against where we want it to be, and you can manage it much better. Because I haven't seen architecture is, I'll give you an example. I was working with a company years ago, and it was actually a product that I wrote, and I sold it to a financial company, and then that was bundled with me doing a 3-month knowledge transfer, which was actually really cool. And they hired a team from India to maintain it. And then I came in on a related work a few months later, and I found out that they had broken like a key architectural rule, which was who accesses the database. And it turned out by circumventing that rule in their design, they were actually bypassing some safety checks, and they actually were introducing bugs because it wasn't going through all of the proper validations. And I realized, I was like so angry, not angry, but I was like, how did I screw up? How did they not know that? And I realized there was no way to measure that. Like, they had no way of knowing that that was true. But what we could do, what I could have done was something like this. This is a measure without going through details that says there's certain packages should not talk to the persistence layer and some should. And you can write code that would check, hey, is anything accessing my database layer that should not be? Because in Java I would have a dependency. If something's in the UI layer and it's accessing the database, I could fail the build. So we have a way of saying, hey, this architectural rule about encapsulation, some of these things would be measurable. And this is sort of what the fitness function is trying to do, is measure these attributes of your architecture and make them measurable and then traceable. And then you can put them in your CI/CD pipeline, where we would have, after some testing, we could put in some fitness functions in here that might just test like some of the code stuff. And then later on, some of the higher level things like performance or security checks, they might be done after we sort of deploy it to some staging environment, or it could even be in production. These fitness functions are sort of a key part. And if we start to do that, then we can bring in logging tools and tracing, once we have it as data, things get, easy to track and measure with whatever dashboard tools that we would want to use. Does that make sense? So the idea is to find some attribute of your architecture and be able to measure it. That's easier said than done. Right? So these things could be hard to measure. And then another idea that is related is this idea of landing zones. So if you're going to land an aircraft on that aircraft carrier, you'd want to be pretty careful about where you land, right? Like there's probably a zone that if you landed too near the front, that wouldn't be good, or too near the back, that wouldn't be good. There's probably a sweet spot in the middle, a target zone where we want to land. And that's sort of what we want to do with our architectural qualities, have a spot where we want to land, and making that clear. So here's an example for, say, a smartphone, where I've defined 3 landing zones, a minimum, a target, and an outstanding. And these, you can see these would be clearly business driven, right? Like, how long should the battery life be for my customers, et cetera. So we can define these different ranges, and then when we're sort of prioritizing architectural work, we can decide, maybe for battery life we really want to be here, but for the footprint we'd be okay with sort of minimum. So we have a way of saying, or maybe we decide we need to get all the minimums first, but we have a way of saying where do we want to be on each dimension of each sort of quality of our architecture. So here's one that might be a bit more software related, availability. And so the problem with architects, often with architectures, is they have some vision and they want to build this sort of super replicating database with automatic failover and a 3 out of 5 voting system to make sure that we never lose a byte. Well, that might be great for outstanding, but maybe just having a hot backup might be enough for us initially. So we should just do this initially, but make sure we can evolve it as we see the need. So I find these landing zones end up being like a really good way to negotiate with the business folks and the technical folks about what do we really need, and making sure that some of the architecture stuff, which might be awesome, might be out in the outstanding category. Maybe that's not the thing that we need to focus on today. So it helps, because I find that you want a way of helping the architects prioritize their work and be able to provide some focus. And I think having these landing zones helps do that. Because you can say, yeah, all the things that you're thinking of are super important, we should totally do that, but maybe not today. Today, our need is this. This is where we need to start, right now. And we'll get to your stuff later, but right now, here's where we need to be. And this should all be business driven. So I want to go back to this and just sort of walk you through how you might sort of tie these things together. Like, let's say you have a business goal of customers can work whenever they want. In other words, we want availability, right? So that architectural quality would then be availability. But notice we've connected it to a business need. We're not getting 5 nines because we think that's industry standard. We're getting 5 nines or whatever because we think that's important to our business. And so then we would define some landing zones. I don't know if you can see that. It's a little fuzzy. It doesn't really matter. It's small.
Oh, that's a lot bigger.
Yeah. So those are the examples I showed you earlier, where our minimum would just be some replicating database. Maybe we have some automated rollback as our target, and down the road we have some 3 out of 5 database like Cassandra or something like that that gives us even more availability. So we define those zones and we decide where we want to be today. Let's say it's minimum. So then that would mean that we're going to add some stories to our backlog. We're going to provision a replicating database. We're going to put in a monitoring service and maybe an automated switch that would switch from one database to the other if we can. So those might not be easy, but at least we've now broken down some architectural work into some sort of stories that we can put into our runway, our architectural runway. This would now be sort of top priority items, if you call that in architecture. And then we build it. And ideally we now have some architecture measures which would be our fitness functions, and now we can deliberately fail it if we wanted to, or we can start to measure our actual uptime and start to get some measures of that. And then we can loop back and then find out, is availability still where we need it to be, or does our business demand even higher availability because we're selling to a government agency that has a contractual blah, blah, blah. So you can start to evolve this and grow, improve this incrementally. So that's sort of a first pass through what that loop might look like. Does that make sense? And I realize I'm sort of like skating over a lot of these things.
What if some other parts of the system affects the availability? Yeah? I mean, here for the stories you have provision, monitor, service, but if you, let's say you did a bad decision, the core of the system that affects this, how you capture that.
So then hopefully the fitness function, if we had fitness function in place, it would go down. We would see a drop because of some other design, and then we would have, oh well, that would now be a trigger for us to take some corrective action. So this isn't going to solve any problems necessarily, but at least give you visibility into, are we actually moving in the architectural direction that we want? The problems that you talk about, they're going to happen, and a lot of that is going to be also based on programmer skill and other things, as well as just the technology architecture choices.
For architecture quality, usually there is a couple of performance indicators or KPIs. How we can, in practice, let's say there is not only availability, it can be security as well.
Yeah.
How we adapt the new fitness function? Let's say, are we going to take care of, let's say, looking to different options and invent something new out of those few items that we already talked about?
So I think your point is that you could have lots of different non-functional requirements, and it wouldn't be unusual to have maybe 30 or 40 of them, like scalability, localization, and like on and on and on. So I'm not sure if I'm answering your question, but the idea is simply to try to identify them and measure them. Identify where you want to be on those, and just start to measure them.
Okay, just to elaborate a little bit, likewise in mathematics we have budget function. If we have several PIs, KPIs, and then we want to invent some fitness criteria, maybe later on we can just...
Yeah, I probably won't, because we don't have that much time, but I think the KPI would be your measure, right?
Yes.
That's your, now the hard part is how do you measure it?
Yeah.
Right.
And how to define that? Let's say.
So you're right. I mean, I'm not going into any detail in any one specifically, because these are tough, often difficult things to quantify, and in fact, even perhaps more difficult to measure. But I'm trying to give you a framework for at least attempting to do so.
Yeah, especially since there are not only subjective but also objective measures.
Yeah, most of these fitness functions should all be objective. They should.
We all call it.
Yeah, I think wherever you can, because as soon as you can make it objective, then you can put it in, you can automate it and put it in a pipeline. You use things like usability. I don't know how you could reliably measure, but you could measure clicks to check out. Like, there might be some ways that you could measure it. Yeah, this isn't easy. I have another example, but I think I might just flip through that. But basically, security, we described a minimum target outstanding, etc. We just sort of rinse and repeat. I wanted to show you, this is actually an example from work that I did recently, where we named it, instead of calling it outstanding, they didn't like that term outstanding, because it's sort of outstanding can mean we haven't done it yet. It has that term, so they didn't like that idea, so they called it WOW, but basically the same thing. So we were looking at making a product releasable. So you can't read this one, supportability, security, scalability, and deployability. And we defined minimum, target, and WOW for each of those. This wasn't hard, by the way. This was only, but the product was basically already built, and we're just looking at making sure that it's operational ready to deploy. So these were just other things that were, logging wasn't completely consistent, et cetera. So this became, each of these became backlog items for the teams to work on. And this was a microservice-based architecture, and they had multiple services. So we created a really low-tech dashboard that listed all of the services across the top, and then with these these four non-functional requirements that we identified, then we just started to track where we were. So green sticky meant that it was on target, orange meant it was at least minimum, and red was below minimum. So Elite gave us a sort of a quick way to see, hey, where are we with our architecture? As we've defined it so far. Then this is just a subset just for deployability, but is this operational? Is this operationally ready? That's really what we're trying to answer here. And this helped a lot for people to see, okay, we clearly have some work to do here, on these sort of purpley, is that pink stickies? But I quite like this, and it got people really thinking about it instead of just being in some architect's brain. And a few principles. I just want to. I realize I'm 6:15. I was okay to go a few more minutes. Okay. So putting people first, like this is where you want the workshop, so that you have the developers and the testers working with the architects and the business folks. So we're putting people first. It's not about ramming an architecture down someone's throat, but making sure everyone understands and is on board and that they're listened to. And what might happen, George mentioned, like how do you make sure you have conceptual integrity? You could have a developer that could agree, but at least if they're listened to and their voice is heard, even if they don't get their, they want to use SQL Server and someone else wants to use Oracle, at least they were heard. It wasn't completely, and hopefully there's rationale for why their decision was made. It's about people and making sure that people are motivated and excited, because the last thing you want is having architects with one vision and the developers thinking this is insane what we're building here, and that's just not a good place to be.
So in a workshop like that, would you have an architect that brings a proposed architecture to the group and then they discuss it, or is it like let's build it together? What does that look like?
I think it would be very contextual. I mean, if an architecture had already been built, I would probably want to bring that in, but if an architecture had not yet been built and we were in the envisioning phase, then I would probably have a more collaborative brainstorming what might our architecture look like.
And would you include everyone or more of the leads, or just
Again, very contextual. I would probably start with the business folks and the architects and making sure that the architecture is aligned with the business goal. That's where I would start. And that could be a small group. And then, the landing zones and so on, that would be a next phase. So you might break those into multiple steps and then bring in different people to
Actually, we had last year at this group, we have a workshop how to run workshops.
Yeah.
So to avoid bike shedding,
Yeah.
So you need like an expert, and you need to have different groups and rotate them, so there is no dictator and stuff. But here, the expert on the subject is the architect, and I think you take the feedback, but then you have to convince people that your solution is good.
And I've recently got asked to facilitate these workshops, and that might be a good idea, so that you have somebody, that's not attached to a particular viewpoint to come in to facilitate it, so that you're, the architect isn't in the position. It's really hard if you're an architect trying to sell your vision and architect and facilitate a workshop at the same time will be quite difficult. And whether it's external or having someone else facilitate it, the whole having an effective workshop is a whole other topic. The one thing that I think is, if I could deviate just a little bit, is I think more and more it's becoming clear to me that at least the systems I'm working on, and it might be just because of the systems I work on, but I think we're moving towards a more event-based world, where our systems are responding to events. And I really like that because, like, an example would be, you know, a user clicks the checkout button. That's an event, right? Or, you know, I've been doing a lot of work in the IoT space, so a temperature reading comes in. Now, the interesting thing about a lot of those, let's say a temperature reading comes in, that's irrefutable. Like, it's a fact, right? The user clicks the checkout button. That's a fact. You know, they click the checkout. So if you can start to get people to think about what are these events that happen that are sort of like irrefutable things, then you can get around a lot of the debate about architecture, because you can say, oh, when this event happens, well, what should happen next? When they click the checkout button, there should be a check that they have sufficient funds on their, you know, whatever, that their credit card is valid, and that's another event. So the more that you can get start to think of the system as events, then I think it helps, business people get that. Oh, the checkout button, security check. So you sort of close the gap between business folks and technical folks by speaking in events, and those events should be meaningful for this world. So there's this whole workshop called event storming. I don't know if anyone's heard of event storming. That's geared around doing architectural workshops that are based on events. And the good part about that is that will lead you to an event-driven architecture, whatever that might be, which happens to play really well with microservices. So I have not yet facilitated an event storming workshop, but I really want to, because I think it makes a lot of sense. Shared prioritization, I'm about to work with a client, we're going to do this, and this would be like building a story map that would include your architecture work along with your functional work, and those could be prioritized together. Architect as mentor, instead of being the ivory tower, like I think nowadays, if you want to, you know, my personal feeling is if you want to be an effective architect, you should be able to code it. Whatever you ask them to teach people to code, you might not be the best JavaScript programmer on your team or whatever, but you should feel like you could code it. And so then when someone's working on it, you're able to come in and help them do it. Or at least guide their thinking, even if you don't know the language, but be able to participate and help people understand why these architectural decisions are made and why it's important, and help them through putting that architecture into place. And a community of practice is often a good idea. So we have another client I'm working with has every week they have like a forum, a 1-hour forum where they discuss architectural things. They bring people together to talk about emerging concepts or maybe some problem they're having in their architecture. So there's a few key takeaways I hope I leave you with is sort of this, using these landing zones and fitness functions to guide your architecture and help people break it down into what can we do today to meet minimum and how can we measure it and guide it rather than say, here's the ultimate architecture that we have to build. Aligning it with business really helps weed out the sort of like, well, I think Kafka is better than RabbitMQ, or I think SQL Server, like, get away from that by saying, like, you know, what's important to our business, and use that to ground your decisions rather than sort of technical preference. I talked a lot about fitness functions, making things visible, and collaborate. And this is the book that I mentioned that is quite good. I wouldn't say it's an excellent book, but I would say it's a good book. And it's not excellent only because it's slightly, like the content's all good, but it's not, it feels a little disjointed at times. Like it's sort of like not like a super smooth read, but there's a lot of, almost everything I've talked about in this presentation has come from that book, except for landing zones, which I got from elsewhere. So that's it. I hope you got something out of the talk. And yes?
In this book, do the authors give example, like what examples? Because my feeling is that the architecture is seen from outside in. I mean, you use these measures, yeah, to evaluate, but how you go doing it practically to change the code, for example, or to, you know, once you take a decision, do they go into like design practices or their architecture patterns, for example? Do they go into that?
There is some of that. I forget, it's been a while since I read the book, but it's primarily around making sure people understand that you're trying to build an evolvable architecture, and you're trying to defer and make changes, make decisions changeable. In terms of sort of like architectural patterns, there's definitely some technical stuff in there, but it's not like it's not a design on how to build great architectures. It's more about how do you put a system in place that lets your architecture evolve over time effectively.
Do they have use cases, exactly with different fitness function, for example?
Yeah,
or,
there's some they don't have a lot on fitness functions, but they do have a few examples. That Java example came from there. So as I say, it's a valuable book. It's not a great book, but if this is a topic that interests you, you should definitely check out that book. There's goes into a lot more depth than I've gone into here. Any other questions? Yeah.
I have a general question, but just make it a short answer, right?
Okay, I'll try. It's not my forte.
You mentioned event-driven architecture. To me, that's a totally foreign concept. You have event-driven programming in your architecture, which it works within.
Right.
How do you say a click on something is architecture?
Because it's a meaningful business event, I guess. So, like.
But isn't architecture considered the umbrella?
Yeah. Well, I'll give you. Here's how I think. Think about the Internet of Things, which is where I've been working, right? And to me, if I step back and think about the Internet of Things, I think of it. Set aside the control functions, how you enable and configure things, but just think about what's happening 95% of the time. You just have data streaming, like you have cars moving and temperatures reading and humidity measures. You just have data flowing, right? Each one of those things is an event. So I would want my architecture to be really, if I were designing a system like that, I would want my architecture to be tuned to that context of responding quickly to events. And what that might mean, which I think would be a really good idea, is I would write small little services that would be receiving these signals from the field, and they would do nothing except one thing. They would publish their event on an event bus, like Kafka. So now we're talking architecture. Are we going to have a message bus in our system, right? And then that would be all they would do. And then things that have business logic that actually, if the temperature goes over 100 degrees, then send an event. They would be listening on those events, and now, so by thinking of things as events, it lets us decouple our systems. I think our world is going event based, and for a lot of reasons. And when I'm building systems, I like to have a consistent metaphor throughout. So for example, if I want my vision for the system, and some people in extreme programming, they would call this the system metaphor. So my system metaphor is just data streaming through. I want my architecture to reflect that. I don't want to have this service reads it in and stores it in a database and someone else pulls it. Like right away, that just doesn't fit my architectural model of data's just streaming through, right? And then when I'm writing my code, I would want to be, this is a longer essay, but when I'm now designing this microservice, I would want to have that same concept. I would want to have something that opens up a socket connection or something, and now it's streaming data through. So I have sort of conceptual integrity in my system where everything is responding to events and streaming data. So I like when there's architectural alignment around my highest level architecture and the lowest level code that I'm writing. I like that.
You're talking about compatibility, basically, between the code and the architecture.
And not to models, because I don't have to think, if I'm at the architectural level, I have to think about JSON REST and all these things, but if I'm at the code, I want to have it like everyone's thinking about how do I respond effectively to an event and what do I do next? And that should be sort of at all levels in the system. So if I can get that conceptual integrity, I think it helps people build systems.
Perfect. Thank you.
Yeah, that was a long answer. Sorry.
No.
Any other questions? Cool.
Maybe
yeah.
comment. There was a talk here by Todd from magnetic forensics.
Ah,
And like your talk resonates with what they were talking. Like he said, when we went to the object things, like we start to treat everything like objects, but not downgrading, but more talking about what happens with elements of the system. And objects are what happens to you. So it's an event thing. And basically, sort of, what he was saying is like what you are saying is the event-driven architecture, like I
Yeah.
guess parallels. Especially that object-driven architecture is
Yeah.
messaging, sending things, right?
Yeah.
They got it wrong in Java.
my prediction is our systems will move to more and more event-based.
Yeah.
And I found in my work, I'm moving away, like I've done object-oriented programming for years and years, and now I'm avoiding object-oriented programming, moving to much more functional or much more functional design, where you're just writing functions that they get an input and they have an output, that's it. And there's minimal
But
state.
that thing is
Right.
actually an object which you deploy.
Oh yes, it's an artifact.
Yes, it's an artifact, but it's still an object. It's
Well,
an element of the system.
It's
It
an
does a
element of the
little-
system, just maybe object is an overloaded term.
Yes.
Because if you say
Yes.
object, people
Yeah.
will assume object-oriented programming.
Yeah.
And I'm finding with event-driven systems that you really don't.
Just don't confuse.
Yeah, because, I don't know.
Maybe I can give you an example. Coming out of the world of industrial controls, programmable logic controllers, they run their programs
Mhm.
every 30 milliseconds.
Mhm.
So they go through and look at everything and make a decision. 30 milliseconds later, they make another decision, like they rerun it. Like,
Yeah.
you know, and longer story, but that's very different from somebody that came out of the finance world and took numbers and added them together. I mean, and now where we've gone is we're in planning. We do day of operations software, and big companies that do long-term planning, they're trying to get into day of operations software, but they think in terms of like, what do I need 6 months from now?
Yeah.
Now when they need, well, something changed now, what do you do? Well, because of our background in controllers that are always thinking quickly and making decisions and then making the decision again a minute later, you get a different feel. So,
At the risk of boring, I've spent about the last year really trying to understand functional programming, and it's been really interesting. And the thing that I've learned the most is that a lot of the things that I brought into the way that I would architect and design systems was really motivated by an object-oriented bias, which I was unaware of. To me, having controllers and models and views and all of these things, that was just good architecture, that was just good design. But all of those things are primarily predicated around having sort of an object-oriented orientation. And we try to model the world in objects, and we try to sort of and it turns out that when I was able to release myself from those biases and just start to think about what actually needs to happen, I found that a lot of the object-oriented stuff that I thought was super good and super valuable before became unnecessary. There were much simpler ways to solve these problems. So it was an eye-opener to me, and I think you're going to see, my prediction is, we're going to see much more event-driven stuff. And what really works well with event-driven is just having functions that respond to those events and do something else. So I think you'll see more and more functional programming over the next decade. But I could be, I've been wrong many times. I could be wrong there, but that's my prediction.
Do you see a parallel between that and microservices?
Definitely, yeah. All the microservices I write now are extremely functional. Like I try not to have any state at all. And if you can do that, you end up with huge scalability, because as soon as you don't have any state, you can run hundreds of them. You don't need to communicate. So I think that's where we're going to go.
So I was going to ask for your opinion on the role of the architect. So we're making an agile transition, and some of the teams are taking the agile mindset to heart and saying, well, what is the architect for? But I think some of what I'm hearing is that the architect is more closely aligned with the business to ensure that the team, that the architecture addresses business needs. Anything below that belongs to the team anything that the business cares about, the architect.
That's a start, but often, like, most of the architects I work with have been like super smart, experienced folks, so you also want to be able to have them, you know, inform, guide, and bring their knowledge to bear on the problem without feeling like they're doing. So it's I think there's an important role there for the architect as well to guide and mentor.
Yeah, can we say a coach? Basically,
Coach,
a coach for developer.
Yeah.
But sometimes, like, how do I do this? Where do I start? And
Yeah.
the coach should answer that question because he architected it.
I mean, really big systems need a roadmap.
Yeah.
You know, I mean, that's all there is to it. And then you need somebody to maintain the roadmap.
Yeah. Yeah, well, yeah, big legacy systems are a whole other challenge. Speaking is sort of very challenging. I realize I've gone way over and you probably all have things to do. Go to your question?
I just want to make a comment about that you said events-driven stuff is where you think it's going. I would argue the reason why you're saying that a large amount of data is not coupled.
Right.
And so the functionality is isolated to a small amount of data. And that's why you can do it in streaming architecture and things.
Yeah.
You don't have to optimize for how to get all the data and connect all the data together. For the old systems, they were
Yeah, you have to
perhaps
have
less data, we had to know about. The complexity was how do you connect all the pieces together to produce your information.
Yeah.
And so what you're finding now is that the data scale is where you're having the problem. And you can't build a system at that scale that actually also has the interconnections between the data.
Right.
So you're right in the fact that a lot of new systems will go to this data streaming approach. But what they really want to do is have both. They just don't know how to do that yet.
So you start collecting the temperature sensors from 4,000 points in the city to see where things are happening. Yeah, you need to have some decent databases.
Yeah.
You know, or collection
But you know,
of
but
data.
these are becoming like you know, in the old days, you know, we used to say, what's a good example? Like, I've never optimized my code for performance. I just rarely, if ever, do that. Right? I'm going to optimize my code for readability, for human consumption. Not to, like, I'm not going to make code more complicated because it's more performant.
Maybe you change your design to fit the optimization.
So I'm optimizing for maintainability and ability to
Because
add
your
code.
architecture is changes depending on what the volume of the input is.
Yeah.
It's an optimization of design. It's not necessarily an optimization at a low level. of
Correct.
code.
Correct.
So you change your way that you're doing your architecture to fit what you need to optimize.
Right. Yeah, exactly. And what I see happening is that, you know, people now are realizing it doesn't make sense for me to fine tune this for loop. I just let the compiler handle that. That's not something that I need to optimize. And I think that's happening, starting to happen now more at the exascale. Like, we don't need to design or figure out how to create, you know, multi-terabyte databases that are distributed. That problem's been solved by lots of people. You know, getting scalable services and, you know, scale on demand. That's now, all of these are becoming solved
You can go buy
problems.
that.
Pardon me?
You can go buy that.
So we shouldn't try to architect at that level. We should try to say, you know, hard disks are cheap, CPU is cheap, network is cheap, and just design my systems to be as simple as I possibly can. It's sort of where I'm going, right? And so if I have to spin up 100 servers or 100 replicas of some service, who cares? My Amazon bill just went up $100 a month. That's probably peanuts in my organization. So I think we're starting to see people shift away from, especially move to cloud and you know, PaaS and SaaS-based services that we can optimize at a different level.
I think you're going to get, yes, that may be true right now, but it's only when you have large amounts of large amounts of revenue for the amount of processing. So that's the kind of systems that you're building are ones where corporate people care so much about what's coming out the other side, or the amount of money you get for the amount of processing is very high. And so you can waste the processing and not worry about it.
Right, exactly.
Where there's a lot of systems that are online systems that they don't have that luxury.
Right.
And those are the ones you have to worry about actually optimizing. So you reduce that bill for Amazon.
Yeah.
And so you reduce it so that to the point where you can actually make money, right? So yes, the people that you're dealing with don't have that bigger problem. It may still be a problem for them, but it's not a big problem for them. But for a lot of other people, that's probably not true.
I think
for a lot of startups, that probably isn't true.
I say for most startups it is true. I don't want to get in an argument with you or it'd be something a really big discussion, but like, you know, I was a CTO of a startup and, you know, we just spun up instances on Heroku, paid, you know, $50 a month, bang, I didn't have to worry about all sorts of things. So I think people are, even startups are definitely leveraging these services so they don't have to invest in architecture. But it sounds like a deeper discussion. I think I get what some of your points are really valid. I just think we're moving more and more to where these things are now just infrastructure things that we can rent. And we shouldn't optimize our designs for those in my opinion. Definitely in other, you know, in some, there's lots of cases where you should care. Like if you're Netflix, you might, well, Netflix is interesting. Netflix rents all, like they have nothing in-house, right? No servers in Netflix are in-house. It's all external.
It's a really interesting presentation by Gojo Padzic at GoTo earlier this year, talking about how he moved his service called MindMap. It's a publicly available mind mapping tool from his original platform to Lambda, and he shared. He actually in the presentation put up his AWS built for the month. He's supporting 400,000 users, and it was like $120.
I want one of those.
And he walks through the whole process and why they did it and how we got to optimizing for exactly what you said that program. It was just startling.
Yeah.
Startling.
And again, it's sort of interesting, you know, in this Lambda, so it's all function and event responsive. So I think our world is going there. I think we have this false notion that our world is very transactional and that we need guarantees. Because most of the time you don't. And, you know, you can always, you know, we try to impose this synchronous viewpoint on our architectures when really our world is essentially asynchronous and functional. Is sort of my belief, and I think we're going there. I could be wrong. I could be totally wrong. But that's where I think we're going.
Coming out of the shipping business and all that, yeah, it's going to be a while. I mean, but that's where true blockchain and distributed registers start to become an interesting thing. And then the real extreme is Bitcoin. Now they're just burning up so much power. You know, I mean, there was an article recently. You know, some city that if they have a power problem, they're just going to turn on all the Bitcoin miners.
That's a good idea. Anyway, I went way over. I really enjoyed the questions. So thank you.